potassium nitrate decomposes to potassium nitrite and oxygen gas. Let's list the elements. So this L is for the left side. So let's count. We have 1 potassium on the left side. Nitrogen we have 1 on the left side. Oxygen we have 3. Okay. On the right side we have 1 potassium, 1 nitrogen, and oxygen we have 2 here plus 2 here. Okay, I know there are 4, but there's a reason why I write them this way. It makes it much easier to balance them. So let's see. Now the K and the N's are okay, 1 and 1. So now let's focus on the oxygens. On the right side you have 2 plus 2, so there are 4 here. Let's make this here 2. So this 2 means that we have 6 oxygens on the left side. You see that splitting this into 2 makes it easier because we have 2 here. This 2 is affecting the K and the N. So that means that on the right side we have to do the same thing over there. So that means we need to put 2 here, so that this 2 is now affecting everything here. And so now the oxygens here must be multiplied by 2. Now we have 2 times 2 is 4, 4 plus 2 is 6. So now everything is balanced. So this shows that it's very, very important to split elements, make it easier to balance them. Now we can rewrite the equation again. Now we are done. Phosphorus oxide reacts with water to form phosphoric acid. It's a combination reaction. Let's see if this is balanced, and then if it's not, we can balance it. So let's write the elements or the items. We have P for phosphorus, then we have oxygen, then we have hydrogen. So on the left side we have, count them, we have 4 for phosphorus. And then the oxygens we have 10 plus 1. Okay. The hydrogens we just have 2. On the right side, hydrogens we have 3. Phosphorus we have 1. The oxygens we have 4. So this is not balanced because if you count the number of elements on left and right, they are not equal. So let's try and balance them. Let's start with P first. So we have 4 here, we have 1 here, so let's make this 4. And this means that we have to put 4 in front of all this. Okay. This 4 affects everything here. So that means that for H's we have 3 times 4 on this. Now 3 times 4 is 12, so we have 12 H's on the right side. That means that we need to change this or multiply this by 6 so that it becomes 12, and therefore we need to put 6 here. So let's tackle the oxygens. Now this 6 here affects this oxygen. So that means that we have 6 plus 10 is 16 on the left side. Now we already have 4 here, which is affecting this. So I forgot to apply this by 4. You see that 4 times 4 is 16. So the oxygens are now balanced. Now everything is fine. So the equation is balanced. Now we can rewrite the equation again. So that's a balanced equation. Reaction between magnesium oxide and nitric acid. Let's list the items. So we have magnesium, we have oxygen, we have hydrogen, and then we have a group of atoms that form one entity. So this is nitrate, that is NO3, and this appears on both the left and the right side. Sounds on the left side here, we have one magnesium, that is this, only one. Then oxygen, I'm referring to this oxygen, we have only one. Of course there's one here, but that is together as a group, so I'm not counting this one because this NO3 is just one thing all together, so which is just one here. And for hydrogen we have one. Now on the right side, which is the whole of this side, we have one magnesium, and then the oxygen, I'm referring to this oxygen, we have only one. And the hydrogens, we have two. Now the NO3s, we have two because they are in brackets, two outside, so we have two, that is this. Okay. So using this group method, it makes the balancing much easier. From here, the magnesiums are okay, 1 and 1. Oxygens are okay now, 1 and 1. And the hydrogens, 1 on the left side but 2 on the right side, so the whole equation is not balanced. So the nitrates and NO3s one left side, two on the right side, so everything is not balanced. To balance this, we can just multiply this by 2. Okay, and then put it in the equation. Okay. Now this 2 affects this whole thing. So that means we have to multiply this. And that takes care of it. So now both the hydrogens and the nitrates are balanced. And everything is balanced now. So we can rewrite the equation again. That is alright. So that's the balance equation. Now you see that I was using the group method, and this way the group should appear on both the left and the right side. Okay, if it doesn't appear on both sides, then we cannot use this method. But in this way, in this example, the NO3 appears on both sides, as the left side and then the right side. So that's the reason why we group them together this way, and this made the balancing so easy. There is another way where you can even split this water H2O into HOH, but because we don't have OH on the left side, we cannot use that method. Okay. So we are done. Okay. So this is a reaction between aluminum hydroxide and nitric acid to form aluminum nitrate and water. So let's write the formulas. These are the formulas of the chemicals listed in the reaction. Aluminum hydroxide, nitric acid, and there's aluminum nitrate, and there's water. Okay. Now let's list the items and see if there's balance or not. So I'm going to use a grouping method. Now you'll notice here that instead of H2O, I wrote HOH is the same. I just wrote it this way to make the balance much easier, since we have OH here. So we can have OH on both sides of the equation, both the left and the right side. In that case, we can group them together as an entity and balance the equation. So in the whole equation, we have aluminum, and then we have hydrogen. Okay, and then we have OH as a group, and then we have NO3 as a group. Okay, so using this group method makes the balancing much easier. Let's count and see if the equation is balanced or not. So at the left side we have only one aluminum, one hydrogen, we have one, and the OH we have 3, and then the NO3s, we have only one, that is this whole thing. Okay, at the right side, this side, we have only 1 for aluminum, and then the NO3s, we have 3 into brackets, so we have 3 of them. And then hydrogen, referring to this hydrogen and not this one, because this is with OH, so only this hydrogen, we have 1. Then the OH, we have this. So that OH, we have only 1. Okay. So the aluminums are okay, the hydrogens are okay, but the OH and the nitrates are not balanced, because we don't have equal numbers on both sides. So let's balance. Let's balance the OHs. Okay. So since here is 3, if you have 3 on the left side, we should multiply this by 3. And that means that we have to write 3 here. Now this 3 affects this hydrogen too. So that means this hydrogen is not 1 but 3. So that means we need to multiply this and put it in the equation. This 3 also affects the NO3. So that means we need to multiply this by 3, which takes care of itself. So everything is balanced now. So now we can rewrite the equation again. That is, we have, okay, so we are done. The equation is balanced. Now you see how powerful the group method is. If I've written H2O here, it would have been more work to do. So the best was, if you see that there's something here like the OH here, you can split water or write it as HOH. That will make the reaction much easier to balance. In that case, you have OH to group as an entity left and right. So here our group OH and then NO3, they appear on both the left and the right side. So that makes it easier to use the group method to balance the reaction. This reaction between ammonia and oxygen to form nitric oxide and water. So let's see if this is balanced by writing down the elements and counting them. So the elements that we have here are we have nitrogen, we have hydrogen, then we have oxygen. Okay. Now on the left side we have just 1 nitrogen. For the hydrogens we have 3 on the left side. Oxygens we have 2 on the left side. Now on the right side we have one nitrogen, then two hydrogens. Now the oxygens, they are split into two. So 1 plus 1. Okay. So let's try and balance them. Now that's not balanced because they don't have equal number of elements on both left and right. So the nitrogens are fine, they are okay now. The hydrogens, we have 3 on the left side and 2 on the right side, so they are not balanced. Let's balance them. We can multiply this by 2 and then this by 3. So doing that, that means we have to multiply this by 2 and this by 3. So the hydrogens are fine now. Now let's see what this does to this one. This means that this N is also 2 now. As the nitrogen on the left is now 2. That means we have to make the right side also 2. And this means we need to apply this by 2. So the nitrogens are fine now. The hydrogens are fine now. The oxygens 2 on the side. On the other side we have 3, that is this. So everything is fine except the oxygens. We have 2 plus 3, which is 5 total. So we don't want to make any mess, but in this case we have to use a fraction or a decimal, and to do that, since this is 5, we just have to come here and then multiply this by 2.5. Okay, that means that we have 5 on the left side. So to write the equation again, we have 2. So this balance equation, alright. The only difference is we use a decimal here. Now we don't usually like to have decimal, we like to have whole numbers. So to change this to a whole number, we need to multiply through by 2 to change this to a whole number. So now we are done. Everything is balanced now. Okay, this is a summary of balancing chemical equations. So I am listing the most important things that you need to know to balance chemical equations. The first one is learning how to write a proper chemical formula of compounds. I will show a video of this later on, but this is very, very important. The next one is learning how to write reaction equations from chemical compounds that you're given. So this here is representing a very simplified statement of what I'm talking about. That is, every chemical compound has a positive side and a negative side. If you are able to identify which side is the positive and which side is the negative side, you can easily combine them to write a chemical equation. So this, for instance, is AB. They will not show you the positive side or negative side, but you have to know this. Okay, so they will give you AB plus XY going, and then you will write the product here. So if you know which side is a positive side and which side is a negative side, all that you need to know is just positive always combines with the negative side, so just exchange the negative and positive and you get your products. That's very easy. Yep. So that's just a simplified chemical reaction equation. Yep. You can even write an example from sodium. Let me try and write an example. Let's say we have sodium hydroxide plus HCl, and then they're asking you to write the products. So you have to know that sodium is a metal, as usual has a positive charge, and then the OH has a negative charge. Hydrogen usually has a positive charge. Chloride usually has a negative charge. If you know this, you can easily write the product. That is plus HOH. That's all. If you can identify which part of the compound is positive and which part of the compound is negative, you can easily write a chemical reaction equation. And then the next thing that you need to know is how to list the items or elements in a given compound that you're given. So this we have gone through in the videos. And then the fourth one is learning how to use the group method and the split methods. The group method is very useful in balancing ionic equations. I will show that in a different video. And then the split method is very useful in balancing decomposition reactions or combination reactions. And then the last step is you can use decimals also to balance chemical reaction equations, but try and convert them back to whole numbers in the end, because it's very easy to deal with whole numbers than decimals. So this is all that I have for the summary of balancing chemical equations.